Welcome to your Lesson 11 of CAD 100, DFT 122, whatever class you happen to be in. And we are talking about dimensioning standards and styles. So this lesson is primarily just geared to showing you how to properly dimension drawings and to set up correct dimensioning schemes and to best interpret dimension practices. Okay. So we're going to take a look at a couple diagrams in your text, primarily on the screen. You can follow along on your book if you want to. But we first have to kind of evaluate what the best type of dimensioning practice is applicable for your particular profession. So to do that, we're first going to go to the next page and take a look at this figure right here and talk about some of the terms associated with different dimensions. Now first off, we have a couple objects right here and here. Here's an object and here's an object. Alright? So let's determine some of the different types of dimensions and the names that are used with that type of dimension. First off, I'll draw your attention to this dimension right here, the 4, which means it travels 4 units from this surface to this surface. Okay? Now, a couple terms. First of all, you have your baseline or datum, which runs along this plane. This also is a baseline or datum. You have your dimension text right here, your horizontal dimension, the fact that it's actually running horizontally from this point to any point along this point horizontally across the page like that. You have some dimension line spacing, some terms that are specific to AutoCAD. You have your extension line offset, your arrowhead, a dimension that is vertical, a continuous point-to-point dimension, as shown right with the combination of these two. Over to our left, you have, of course, an extension line which runs from the dimension arrowhead to the point of contact with what is dimensioning. You have a degree dimension itself, and some other terms that you've probably come to know, for example, the bi symbol there, the diameter dimension, a radius dimension, center marks, and then additional leaders, as you see here. Okay? These are all terms associated with AutoCAD specifically. Now, different programs may have similar terms, but when you go to set up dimensional units and settings, you will need to be familiar with these terms. So definitely pay attention to 446 in your text or wherever this figure is located, in whatever textbook you're using, and interpret the terms that we will use in this lesson with what they refer to on an object. Okay? Now, to be more simplified, we take a look down at the lower part of the page and we see a basic dimensioning plan. And it shows the term called unidirectional. What it means is that the text is always horizontal across the page. Even when doing a vertical dimension, vertical meaning this direction here, the text is still horizontal. Parallel would mean that this text would be lined up with a line, so you would see the 1.5 running this way, which is typically unused. So just note that we'll primarily be using unidirectional. A couple things to notice with this particular diagram. I'll zoom in real quick. Notice a couple things about the dimension itself. First of all, we can tell by this dimension that the distance from this surface to this surface, or any point along this plane, has a value of 1.25. And that's pretty understandable. A couple things to look at how they dimensioned is, look at the quality of the arrowhead in proportion to the size of the text. It's pretty close. Look at the fact that you have extension lines running from their point, but there is a space. See that right there? Let's zoom in real close. There is a space between the dimension extension line and the actual point in contact, because right here is the point in contact. And we like a nice clean space in between the two. So that's good proper technique. Notice also that the extension lines extend beyond the arrowhead. That's also part of proper technique. And the text is clearly readable. On this part, we have a couple things too. Again, notice the nice, neat, proportional arrowheads, extension lines extending beyond the object, space between the point of contact and the extension line. and the fact there's space between the text and the dimension line there. So there's good settings associated with proper dimensioning techniques, and one of those things that we'll kind of learn as we go along. Just keep in mind that it's very important for your dimensions to look good. Notice also there's not an excessive amount of zeros after the dimension, and that's very important. Now we understand clearly that from this point to this point is a value of 1.75. From this point to this point is a value of 2.5. And we notice that it's a horizontal dimension, meaning that it's not angled like this. And that's critical. From here to here is 1.5. And from here to here is a vertical value of 2.25. Okay? It's all important stuff that you have to keep in mind as we go along. On the next page we see an example of architectural dimensioning for house plans and such. So let's take a look at that too, as this will probably be something you'll see as well, or have to interpret. In architectural work, we typically dimension from one point to the next. Since the objects in question in architecture are usually large, precision down to a 1/16th or 1/8 of an inch or even a quarter is not really necessary. So what we do is we start off and we typically go from a corner to a center point of some object, in this case a window, to maybe a center point or an edge of a wall, to the next center point or edge, and to the end. And so you'll notice that there's a dimension between here to here, here to here, here to here, and here to here. Then there's a dimension that gives it for the room zone, and then the overall construction, and then the overall dimension of the entire face of the house, from here to here. So this is a great little example of how to dimension architecturally, because architecturally is much different than when dealing with mechanical features. Center-to-center values are often used in architectural, or locating center of objects. Now, the reason the window is not dimensioned from this point or this point on the corner of the window is because the window may be subject to change. Therefore, by dimensioning to the very center of the window, it allows the window size, for example, let's say it's a 3-foot window, to be changed to a 4-foot, and it will not affect the actual location of the window being centered on the wall. Same thing is true with doors. Doors are not centered to the edges. They are measured to the edges. They are centered on the door as windows. And that's just good practice. That way, in case you make a change, it won't affect the overall plan or layout of the room. Now, there are a couple of terms to note associated with dimensions. And here's an example of size dimensions. We term size dimensions to be dimensions that relate to the size of an overall part. For example, this dimension relates to the size of that hole. This dimension relates to the overall diameter of the part, as does this dimension and this one. These are all size dimensions. Below is an example of a location dimension, meaning that it locates features. Notice that this dimension locates the center point of that hole, and so does this dimension. These are locations. Same thing here. You'll notice there's no dimension locating or sizing the overall part from here to here, or from there to there. Those again would be size dimensions. Locations typically work for circles, for notches or features, or particular locations of cut holes, but not size. Notice the difference between the two because it's important to remember those two terms. Now on the next page is a great example of rectangular coordinate location regarding to patterned objects. For example, here we have a object that has a patterned set of holes. Well, notice that it's simply dimensioned by saying, okay, there's a diameter of 2 along the center line of all these holes. There is a location dimension locating the actual center of this pattern, and there is an angular dimension locating the spacing between two using angles. This also is a location dimension. So this is an excellent example of how to do pattern dimensioning. Here's another. Here you have the spacing. Here is the spacing between hole to hole. Here's also spacing, which is location, and spacing from a corner and a corner. Probably would have been good had they shown the actual diameter size. Here's another example. The idea is to simplify the dimensioning system as much as possible. Instead of dimensioning each individual hole, When symmetrical, you can just dimension a couple and get the point across. Simplification is very important in what we do so that we don't confuse the person who's building our particular part. Now the next thing we need to talk about is format dimensioning. Let me quickly get rid of these first. We'll go on. There we go. Proper dimensioning for the two. Now we've already spoken about architectural. Now let's speak about mechanical in its true format. Right above we have two views of parts that we've seen before. And the format that we want to pay attention to is the fact that there is a dimension from here to here, and there's a horizontal dimension from this point to this point. Notice that it doesn't just go from here to here and then from here to here. That is critical. Here's the reason why. If I happen to make a mistake on this dimension, it will affect this dimension and therefore affect the overall size of the part, which we don't want. We don't want small mistakes to change over the whole thing. So what we have is a term called datum dimensioning. Datum dimensioning works from one point for horizontal dimensions, or one surface, and dimensions from here to here, and then from here to here. Then you'll notice also that there is a datum dimensioning from this surface, from here to here, and then from here to here, to establish the whole part. That way, if I make a mistake in manufacturing this particular dimension, it will not affect this one. Same thing is true here. If I make a mistake with this one, it won't affect this one. And that's critical, because we don't want to make a mistake on this one and then have a part that is overall the wrong size. So we typically like to dimension from one surface to all the others, and then choose it in the horizontal, and then choose another surface such as this one and dimension from it all the vertical. This reduces the amount of error that will occur in the manufacturing. Now that's mechanical. Again, as we spoke earlier, architectural is not that way. You can dimension from one point to the next. See? These all build on each other. So for example, zoom in. If I make a mistake on this dimension, it will affect this one, this one, this one, this one, and this one. And of course it will affect the overall size of the house. However, the fact is, if I'm off a 1/4 inch or 1/16, it makes very little difference in the grand scheme. So that's why in architectural we just go from point to the next point instead of a baseline or datum. Okay? So keep that in mind. Architectural, you go from point to point. Mechanical, you go from a datum and work your way across horizontally and vertically. All right? Key differences between the two to remember. Now, when you're dealing with cylindrical shapes, here's a nice little diagram to look at. When dealing with circular cylinder or holes, you can get by with just using a dimension to show the length and a size dimension with a little diameter symbol in front of it to show the overall diameter. You'll notice that this view does not have a dimension associated with it because it doesn't need to. This one and this one take care of it. And that's typically how we dimension cylinders. Now when dealing with square features or rectangular, you can do it this way. You have a size dimension showing the length, a little dimension and a box in front of it to show that it's square, and just one value. So basically I can dimension this entire box extrusion with only 2 dimensions. And also here's an example of what to do with particular rectangles. You have 3 dimensions here, one for length, height, and width. And that's pretty self-explanatory. And there's some couple of other examples what to do when dealing with cones and hexagons and such. You can show them in these formats. So this is a great little page or figure to take a look at when dealing with particular shapes. Now, with all this information in mind, we're going to do some practice runs. I'm going to create some dimensions or parts to be dimensioned, and we're going to create the overall result. So I'm just going to scroll back here. We're going to practice on this particular figure. So you might as well go ahead and draw this, pause the video, draw this up in AutoCAD, as will I, and we'll get started in learning how to dimension and how to properly set things up. Okay? Alright, well let's go ahead and do that now. Alright, we have the 2 figures on our screen now, and all the sizes are correct based off that image that you saw. And now the question is, how do I set this up in dimensioning? Fortunately for us, there is a complete dimensioning panel for us under the annotate ribbon, so go ahead and check that out. And we have the whole dimension panel, complete with leaders and tables and blah blah blah. Now we won't cover all of it, but we're going to learn the basics. First off, you've got a standard dimension. And actually, if you expand this down, you can see all the different dimensions types we can do. We can do a linear, or a line, or an angle. You can actually put an angle on there. And we have arc lengths, radiuses, diameters, and etc. Okay? We're going to learn all those features here in a second. However, before we do that, we have to learn about some settings. Now, just for example, I'm going to go ahead and draw one on here by using a linear dimension. Click on this point, and it gives me a value. Now, there's a couple things to think about. Notice the difference between my size of dimension and their nice, neat feature. In their case, it's proportional, it's not too big, and mine is. Look how large that is in comparison to the object. So I'm kind of out of proportion. Too many zeros, arrowheads are just a bit big in comparison. You can see some of the differences. Now, with that in mind, I have to make some changes. So what I need to do is find a way to make setting changes on this dimension. Now, one way to do that is to simply click on the object, right-click, and say Properties, or Select Properties, and make all the changes in the property list here as you see. And there's a lot of properties to change. However, the only problem is that will only fix one dimension that I created. If I have two on here, I would have to do the same procedure for both. And I don't want to do that. I want to have all the changes done at once. So therefore, that gives me the opportunity to introduce to you the dimension button right here. See this? Dimension style, a little down arrow. You click on this, and it's going to bring up this nice, neat table. Okay? It's a dimension style manager, very similar to the layer style properties manager, the OPM. This is the DSM, the dimension style manager. So if you hear me say DSM, that's what it means. Okay? So go ahead and find that for yourself. Go to the annotate ribbon, dimension panel, and right click on the little button that says dimension style editor, or dim style, as you see down there. So we're going to go to the DSM, click on it, and we'll come to here, and I'm going to walk you through several steps. So if you haven't got to it, go ahead and pause the video and get this screen available to you so we can step through it up together. Okay? Alright. Now, first thing, we have two different settings, annotative and standard. Now, annotative kind of goes beyond the scope of this class, so we won't worry about this yet. We'll work about it in a different class. But we also have the standard option. Okay? Now, standard comes with it, and it's what my dimension sizes and shapes are as a result of this setting. So I don't really want that. However, I want something new, so I'm going to create a new dimension style just by hitting the new button right here. Click on it. It pops up and it says, what do you want to call this new style? Let's call it Eric style. Eric's. And it says start with. Well, I have the option to start with the standard, which is fine. There's no reason not to start with its standard settings and make adjustments. Of course, you want to say use for all dimensions, and we want to leave the annotative option off. Now, just to explain, annotative is a setting that will work well for multiple scales, but we won't get into that now. Once I have the new style name, the style with which to start, use for all dimensions, this is not checked, it's clear, so I say continue. Once that's done, we now have this dimension style manager, and we are dealing with Eric style. You can see it right here as Eric's. And we're going to talk about all the setting changes associated with dimension styles. For example, there's a lines tab, symbols and arrows, text, fit, primary units, alternate units, and tolerances. All these different tabs relate to settings associated with dimensions. It starts off with the basics, dimension lines. That would be these lines right here. Okay? Well, actually it would be these lines right here. But it's going to be all association with the lines associated with the dimensions. So we're looking at arrows and lines and settings. First of all is color. You can leave it set to by block, but typically we like to be set by layer. Line type, by block, no, we like by layer. In fact, everything about the dimension we typically want to be set by layer. Okay? So that takes care of 3 settings that you want to change. And you want to be pausing the video as we make these changes for yourself. Alright? So I won't give you time to pause. You'll just have to pause the video as I speak and make the changes and come back. Okay? Now, by layer, by layer, by layer. Then we choose the baseline spacing. Now there's going to be a lot of values associated with these settings. They're going to be height values. For example, 0.18, 0.0625. So right now, since our object's fairly small, we're going to take a couple guesses and we're going to see how it works. Alright. So let's say baseline spacing, we'll just leave that at 0.8. We move down to extension lines color, again, by layer, by layer, by layer, and by layer. Okay. Extend beyond the dimensions lines. Well, what does that mean? Well, that means this value right here. How far does it extend out past that arrowhead above? This value right here and right here. And 0.18, let's make all these 0.125. Let's see how it looks. 0.125. Offset from origin, that's about 1/16. That's cool. We can leave that there. And I want to see how this is going to affect my dimensions right off the bat. So what I'm going to do is I'm going to go ahead and hit OK. Since I am kind of done with this particular tab, hit OK. And I will click on Eric's here and tell it to set current. That way, from here on out, any dimensions I make will have Eric's settings associated with it. Then hit close. So I'm going to go back and delete these dimensions. And I'll create new ones. Since Eric's standard is the one set up as the primary, you can see right here under the dimensions panel. I'll go ahead and layer dimension again, click here to here, and there we go. Now you're not seeing a lot of changes. That's primarily because I haven't made a lot of changes to the arrowheads or the text yet. But I have made a little bit of change to the extension beyond this, and that would be the distance from here to here. Okay. In fact, I'm just going to kind of focus on this particular dimension before we begin. Now that I have that set, let's move back into the Dimension Styles Manager, this button right here, and let's continue to make changes to Eric's. Once I've selected Eric, I hit Modify, and I can continue to go down the tabs and make changes. Let's do a big change real quick just to see the difference. Let's change this 0.125, and you don't have to do this, I'll just show you. 0.5, and let's see how that affects the whole thing. Now you can see the difference. Now the distance from here to here is 0.5 and very disproportional. So we don't like that. So I'll just undo that little change I just did. There we go. And go back into the DSM. Okay. Now I'm comfortable with the offset from origin being 0.625. Again, that's about a 16th. That's okay. If I want to make it just a little bit bigger, I may say 0.08. Okay. And close. And you can see the change right there is just a little bit deeper than it was. Nothing wrong with that. So I'll go back out, go back into Modify again, make sure that Eric's is selected, or whatever name you gave it. And we can choose the Symbols and Arrows tab now. Take a look at this. Alright. Now, looks like I exited out by mistake. My bad. Actually, I seem to have run into a slight technical error, so I'm going to close down this video, start up another video, and we'll continue on from there. So, see you in a second.